Welcome back. It's time to sum up Chapter 3 on Linux with this third and final part on the Linux chapter of CCNA CyberSecurity Operations with me, Joachim Kärrestad from the University of Skövde. The one that is noticing things notices that I've changed whatever the third part said before into miscellaneous, because this chapter is about a little bit of everything. Beginning with sudo or superuser do. So the admin account on Linux is called root, and as in Windows, using the root account is discouraged. So instead, you can allow a user to temporarily elevate privileges using the sudo command. So for instance, if you just type netstat and hit enter, you execute as the user that you're currently logged on as, but if you do sudo netstat, you execute netstat with root permissions. So a user that is using sudo will typically need to supply his password, and the actions that the user is taking will be tracked. If you want to allow a user to use sudo, you should place the user in the file called ect or etc sudoers. And you can say that this is pretty much the equivalent of giving the user administrative privileges. On from sudo, let's talk a little bit about packet managers. So managing applications in Linux is mainly done through packet managers, at least for a normal user. And a packet is an application and its supporting files. So using a packet manager to install applications will ensure that the files are placed in the right places and that dependencies are resolved. And a dependency for a package is essentially other packages that it needs to run. If you were to install a package manually, you would manually have to find and install all dependency packages that it needs. So there are several different packet managers available. Usually different flavors of Linux uses one packet manager, and some of them are yum, dpkg, and apt. And apt is the one that is used in the Linux distributions used for the practicals in this course. So let's look at some of the things that you can do with apt. And I want to tell you here that the material is a little bit old, so what I've done for this slide was that I put what the material wanted me to put first, and then I put the newer version of the commands within parentheses. So if you want to install a package, what you basically do is you just type apt-get install and then the package name, or apt install and then the package name. So how do you find packages? Well, you issue apt search, and then you can type in the search term that you want to search for. So if you know that you need a web server, you could, for instance, go apt search web server and see what you find. If you want to download package information about the packages that are available, you go apt-get update or apt-update, and if you want to update packages that are installed, you go apt-get upgrade. So what you would do to look to see if there are any updates, you go apt-get update, and then if you want to update the packages that you have, you go apt-get upgrade. Or apt-update and apt-upgrade also works in newer versions, or basically any version, because it's quite old. So moving on from packet managers to processes and forks. And a running instance of a program is called a process, and forking is a process used to allow a process to duplicate itself. So for instance, the web server Apache can handle multiple requests at once by forking itself. So for every request that you send to the web server, there has to be one fork of the web server, and therefore whenever there is a web request, the process will fork itself, so there is a new process in place for the web request. And when a process is forked, the original process becomes the parent process, and the child is the new process becomes a child process. So there are several commands that we can use to manage processes. Some of the more common are top and ps that are used to list running processes, and then kill that we use to pause, stop, or restart processes. That's it for processes. Let's talk a little bit about malware, because this is, after all, a security course. So some Linux users try to say that Linux are sometimes considered better protected against malware than what Windows is. This deserves a fair bit of doubt. Anyhow, you should know that malware exists for Linux, and you need to protect against it and be aware of it. Some common attack vectors are services and processes. So you target services and processes, and as in any platform, keeping the system updated and be on the lookout for new patches is key to successful device hardening. Rootkits is one type of malware or a set of software designed to escalate privileges, grant access to disallowed software portions, or create backdoors. So essentially, if an attacker wants to have root access to a system, the attacker will try to install rootkit on the target device. And usually rootkits affect kernel code and kernel modules, or even the firmware, and this is a very, very deep intrusion and is also very hard to detect, because if you have access to kernel code as an attacker, it's you have a lot of powers that enables you to hide, making it very hard to find and remove the rootkits. And as the next bullet says, removing the rootkit can be very hard or even impossible. So in some cases you may actually need to do a complete reinstallation if there's a kernel rootkit, or you may even need to replace hardware if the rootkit infected the firmware. So there is a popular Linux tool that is called CHK rootkit, check rootkit, that you can use to check for existence of known rootkits. Sorry for that. Ending this lecture, we'll talk a little bit about command piping. In Linux, it's very possible to execute several commands at once, or at least in turn, to achieve different things, and this is called piping. By chaining different commands, you can execute several commands and feed the output of one command to another command. A very common way to do this is by looking in log files and searching on the fly. So for instance, you may want to read a log file using cat, but you may only want lines containing the keyword warning or some other keyword, and then you can cat to the log file and use the pipe sign to pipe the output of the cat command to yet another command, in this case grep warning, which would output all lines containing the keyword warning. So this is a search in the file of our log messages. So I understand this was a very messy lectures, and the network lectures that are coming up next will also be kind of messy, but I promise you that once we get past that part, it will clear up. As always, feel free to leave questions in the comments field, and until next time.